Well, hello, welcome to the Future Internet course. This is the last part of the course, which is the part of AI meets networking. First, we're going to have a kind of brief introduction of AI and then when AI meets networking. So, as an agenda, here we have first like an introduction of artificial intelligence with machine learning and the types of learning inside machine learning. And then we will see how these machine learning models are used in networking, actually taking into account the OSI model and the network management main tasks and how they can be used in networking, and some research challenges regarding that as well. So let's start in this first video with artificial intelligence. So this is going to be a very brief review of artificial intelligence. Artificial intelligence can be defined as software that actually can solve problems by itself. But when we go deeper and in more detail, normally people think on artificial intelligence, but what they actually mean is machine learning. So in machine learning, we are talking about algorithms that learn from data. So here is when we talk about data analytics, or actually the decisions that we take are actually based on data. So this is machine learning. And machine learning is very important because the idea is that machine learning is programming computers to optimize a performance criterion using data from past known experience. And learning is used when, for instance, human experience does not exist. Example, navigating Mars, for instance, or humans are not able to explain their experience, speech recognition, for instance. The solution changes with time. One example in networking is routing. For instance, routing a computer network can change, or the solution should adapt to particular cases, like biometry. And also, we can think of machine learning where the data amount is so big that it's not possible for a human to interpret, to make the interpretation of the data. So the decision is better taken by a computer, right? So what's learning? This is a good question. So we can define learning as a process by means of which the learning subject improves its performance in a task or a group of tasks as a result of the experience in its relationship with a determined environment. Okay? And if we go more deep in detail, we can say that what's machine learning? Machine learning is where when we have a computer program M that learns from an experience E with respect to some task class T, T is the task class, and performance P. So the computer program M learns if its performance measured by P in the task T in a specific environment C improves with the experience E. So this is the idea, that with the experience that the computer program is gathering, it improves the performance it has with regard to some task. So one example is the task can be cancer diagnosis. I want to diagnose if a person has cancer or not. The experience is the set of diagnosed cases. B, the performance is the precision in the diagnosis of new cases, right? This is the performance of my computer program. And Z, the environment, is the measures with noise, occasionally diagnosing cases that are wrong. And M is a program running in a general purpose computer. Okay, so this is an example of machine learning. So the idea is that the computer program M learns from an experience E. So remember that the experience E is the set of diagnosed cases. So I have a situations like symptoms, right? Uh, and my system my computer program, with the observations that it had in the past and the experience, can learn, right? And it can learn and improve the performance, so it will be more precise, telling you if the symptoms that you have are cancer or they are not cancer, right? So this is a good example on classification in machine learning. So why do we need to use a computer program to do these kind of things? Because some tasks are very difficult actually to infer by humans, so it's better by computer programs. And even with computer programs, it's very some tasks are very difficult to program. Right. For instance, this is an image of communication between or among autonomous cars, and this they have to take into account a lot of variables. So when data is available of past experience, the decisions can be more precise. This is the idea. So we have several types of machine learning. We have the supervised learning, in which we have classification and regression. We have unsupervised learning, and we have reinforcement learning. Okay, I am going to be very brief explaining each of these type of machine learning algorithms. Supervised learning is actually the one more used, and it is a technique to deduce a function from training data. So I already have training data that is already labeled. So I already have uh, historical data with labels on it. Okay, so the goal of supervised learning is to create a function capable of predicting the value that corresponds to any valid entry after it saw before a series of examples that we will call training data. Okay, so let's look at an example here. So for instance, we have classification, which is a very normal application of supervised learning. In classification, we get the labels of the training data. For instance, I don't know, just a set of coordinates, x1, x2, x1 is size, x2 is color, and with some size and some color, I have a y, which is the output saying that this is a tangerine or oh, this is an orange. Okay, so we are interested in classifying a future element. So a future element with some size and some color. Regarding what we have here, we want to know if it's a tangerine or an orange. Okay, so this data is already labeled. We already the historical data. We already know that these are tangerines and these are oranges. The classification is very used in computer vision, actually, and face recognition, for instance. So we have a lot of training sets, training examples of the face of a person, of training sample of cats, which is very useful or very used to teach machine learning. And then we have test images. And then I can classify based on my previous experience, saying that this guy is the one of the historical data that I have, and these other three pictures are not uh, the same person that the one that I trained, right? So this is the idea of classification. This is between two classes. Is he the guy or is he not? But you can have several classes to make classifications in supervised learning. More than classification in supervised learning, you can also have regression. The in regression, the objective function is continuous and not discrete, like in the other case. And what we do is to like uh, foresee what is the value of the new sample. So for instance, we have several sales prices for different houses that we already know. So we have this labeled as a function of their sizes. So this is the size of the house. And I already know that one house of size 60 has more or less this price, of size 100, for instance, has more or less this price, and so on and so on and so on, right? So what I do is to predict, right? It is possible to use a hypothesis claiming that prices are governed by a particular function, and once this function is obtained, the price of any new house can be predicted. So this is a normal prediction function. So if I am talking of, I don't know, 200 here, then I can see the new price here. Okay, this is the idea. Apart from supervised learning, we have unsupervised learning. In unsupervised learning, as you can imagine, the model is not adjusted to the observations. I mean, the difference is that you get data, but the data is not labeled. So if I come here, for instance, I can get this data, but I don't know, it's not labeled as tangerines and oranges. Okay, so I don't know what is what are actually the characteristics of the data because it's not labeled. Okay, so unlike supervised learning, I don't have a priori knowledge of the data. It's not available, so I cannot train the data or the models with prior knowledge. And the training experience does not have any output because data is not labeled. So what it does is with a lot of data, of input data, it tries to cluster the data in different classes, looking at different patterns of the data. So it can detect some patterns and say, uh, for instance, this set of data has this pattern, this other set of data has this other pattern, and then it can cluster the data in different classes, even without labels at the beginning, right? So I have this data here. First, I do some filtering or interpretation, and then I apply the algorithm, make the processing, and then in the output, I can have like 3 patterns that the algorithm discovered right here. So this is the idea of unsupervised learning. It has a lot of applications, of course, to create and discover patterns that are not known in the behavior of web clients, for instance. Detections of anomalies that are not known in advance, or they do not fit in non-groups. If you have, for instance, detection of cyber attacks, but there is a new cyber attack and you don't know it before, so you don't have labeled that data of this cyber attack. With unsupervised learning, you can detect that there is a new thing happening there. You can also do dataset simplification by adding variables with similar attributes, or you can discover groups that were completely unknown before with unsupervised learning. Okay, so it's also very used. So this is a nice picture about supervised and unsupervised machine learning. So if you go to supervised machine learning, you have the data label. So somebody told you that the result is this in the historical data, so you can predict with more information or labeled information before. And then so unsupervised learning, nobody tells you, and the data is clustered by means of the behavior of the algorithm. So what's the best alternative in terms of technique? Inside supervised learning, you have a lot of techniques. Inside unsupervised learning, you have also more techniques, and also you have filtering techniques, and there are a lot of theory in machine learning. So you can have classification, clustering, regression, or dimensionality reduction with different techniques, each of them. So this is a big world in which, depending on the problem you have, you can use different tools. Another learning class, let's say, is called reinforcement learning. And reinforcement learning tries to determine what actions should a software agent choose in a specific environment, trying to maximize a reward. So what you do is that in each step of the process of the reinforcement learning algorithm, from a set of feasible actions, the idea is to choose one to maximize a reward function. So the system learns how to behave, right? Taking into account the reward that you give the system for the action that it takes. So if it takes a good action, you give it a big reward. If it takes a bad action, you can even give it a negative reward. So the system learns by itself based on this reward and not reward mechanism how to behave. So in summary, if you have historical data, you can then classify elements or make regressions via supervised learning. If the data is new and you don't know the data, you can use unsupervised learning to make cluster of different patterns. And if you want to train a system on how to behave, right, depending on the kind of actions that it can take, giving or not giving rewards to these actions, you can use reinforcement learning. This is a timeline of ML algorithms actually, and then we can see that from the 1960s we are talking about neural networks and machine learning algorithms in general. So this is not a new thing at all. The thing is that with the advances in processing computers, it is each time easier to use this kind of algorithms to train systems and to learn from experience. And also, with the amount of data that can be stored now, we will have more possibilities to have inputs for the algorithms, and that's why it's very important to right now to use these algorithms for any task that you can imagine. We are going to talk actually about networking and how machine learning algorithms have been used in networking, but it has a big set of applications. So in the next video, we're going to talk a little bit about ML meets networking and which applications or which networking management problems can be solved using machine learning. Thank you very much.